In this example, we're going to write the formula of a multivalent ionic compound if we know its name. The way you are going to know that you have a multivalent ionic compound as opposed to a different type of ionic compound is by the Roman numerals in parentheses following your metal element. There are two different ways to do this problem. You should do whichever one makes the most sense to you and gets you the correct answer. So the first way of doing this is by looking at valence electrons. So iron with a 3 in parentheses means that my iron has 1, 2, 3 valence electrons. Now oxide is the element oxygen. To figure out its number of valence electrons, you need to look on your periodic table. Oxygen is in the 6th column over from the left if we skip the transition metals. So that means oxygen has 6 valence electrons. Now remember, our metals will always give up electrons and our nonmetals will want to take in electrons. So that means oxygen, our nonmetal, has 2 empty spots it is looking to fill. Iron will transfer its valence electrons to fill those empty spots. The problem is we still have 1 electron left over here on our iron. We have to put it somewhere. You can't have a leftover electron. The only place I have to put it is another oxygen atom. So I have another oxygen. Iron can transfer its valence electron to oxygen. Now this iron atom has no valence electrons left. However, this oxygen atom still has 1 empty spot that it needs to fill. So we need more valence electrons. The only element giving up valence electrons is iron. We need another iron. So I'm going to draw another iron. Same thing will happen. Iron will transfer its valence electrons. Now this oxygen has no empty spots left, but this iron still has 1, 2 valence electrons left over. We need somewhere to put those valence electrons. So we need another oxygen atom. Iron will transfer those 2 valence electrons. And now we have no leftover electrons on either one of our iron atoms, and we have no empty spots on our 3 oxygen atoms. So we're done. We've transferred all of the valence electrons and filled all the empty spots. Now we need to write the formula. To write the formula, you're just going to count. So we have Fe, and there are 2 of them. So we have Fe2. And we have oxygen, and we needed 1, 2, 3 oxygens, so it's O3. So the correct name of the correct formula of iron 3 oxide is Fe2O3. Now there's another way to do this problem, and that's by looking at the charges on each ion as opposed to drawing out the Lewis structures and transferring valence electrons. So I'm going to show you how to do that way as well. Make this a little smaller so I have some space. So what you're going to do is you're going to start with your iron 3 just like we did before. Now iron 3 means that iron has 3 valence electrons. 3 valence electrons that it's looking to give up. If it gives up 3 valence electrons, our ion is going to be Fe plus 3. Oxygen, if we look back at our Lewis structure up here, oxygen has 2 empty spots it's looking to fill. That means it wants to gain 2 electrons. When it gains 2 electrons, it's going to have a charge of -2. So we have an Fe plus 3 and an O minus 2 coming together to form this ionic compound. Now to form an ionic compound, your charges, your plus 3s and your minus 2s, have to cancel out to 0. So if we take plus 3 and minus 2, we do not get 0. So I need more charges. The easiest way I think to do this is just to go back and forth until they cancel out. So I'm going to add another oxygen. Now I have a total of -4 on my oxygens, but I have plus 3 over on my iron. Plus 3 and -4 don't cancel each other out, so now I'm going to add more positives. Now I have +6 and -4, which still doesn't cancel each other out. So I'm going to add more negatives. Now I have a +6 and a -6. Those two cancel each other out. So I'm done. I'm going to do the same thing I did before and count the number of each element. I have 1, 2 irons. So I'm going to start with that in my formula, Fe2. And then I have 1, 2, 3 oxygens. So that's my second part of the formula, O3. Now you can see that I got the same answer both ways. Again, you are going to use whichever way makes the most sense to you. And that could change depending on the problem. Sometimes you might use this list method. Sometimes you might use the valence electron method, whichever makes the most sense for that problem.